When white light from the sun passes through a prism, it undergoes a process called dispersion, where the light is split into its constituent colors. This phenomenon occurs because white light is actually a combination of various wavelengths, each corresponding to a different color in the visible spectrum. The visible spectrum consists of 7 main colors: red, orange, yellow, green, blue, indigo, and violet. These colors are arranged in order of increasing frequency and decreasing wavelength, with red having the longest wavelength and violet having the shortest. As white light enters the prism, it is refracted or bent due to the change in speed as it travels from air into the denser material of the prism. This bending of light depends on its wavelength, with shorter wavelengths, such as violet, being bent more than longer wavelengths, such as red. This is because shorter wavelengths interact more strongly with the atoms in the prism, causing them to be slowed down and bent at a greater angle. As a result of this differential bending, white light is spread out into its constituent colors as it exits the prism. The longer wavelengths, red, orange, yellow, are bent less and deviate less from their original path, while the shorter wavelengths, indigo, blue, violet, are bent more and deviate more. This separation of colors is what creates the spectrum of colors observed when white light passes through a prism. When the dispersed light is projected onto a screen or surface, it forms a spectrum with red at one end and violet at the other, with the other colors arranged in between according to their wavelengths. This is why we see rainbows with red at the top and violet at the bottom when sunlight is refracted and dispersed by water droplets in the atmosphere. The longer wavelengths of red light are refracted less by the water droplets, while the shorter wavelengths of violet light are refracted more, resulting in the familiar bow-shaped arrangement of colors. In summary, when white light passes through a prism, it is dispersed into its component colors due to differential bending caused by variations in wavelength. This dispersion results in the formation of a spectrum of colors, with red at one end and violet at the other, as observed in rainbows and other instances of light passing through prisms.